banging out his NetFlow version 9 implementation. You know, and he's modified it because I don't know if you guys know what NetFlow is. Everybody know what NetFlow is? Everybody play with Cisco routers? Anyway, this is the way you talk to a Cisco or get information off a Cisco router that talks about flows that pass over the gills of this router. In fact, there's something called S-flow that we should get some feeds from on our switches. You know. So there's information that we can glean from a router, and for IP, the older versions have fixed length structs. If you've done C code, it's like a type def of a struct, and these are very fixed slots. Well, there's only 4 bytes for the IP address of version 7. And you know, version 6 of IP requires a 128-bit address, you know, so then you have to go to NetFlow version 9 in order to get that. Well, it turns out it's a little bit more complicated to parse these NetFlow packets if you have variable data sizes, depending on what this interface or that interface traffic will send. So, how do we know that my buddy Brian did a good job? Did he break version 7 of NetFlow? You know, so, in fact, Anna's got a fellow that he loves generating NetFlow. So flow generation ends up being one of those kinds of things. So these flows are not only raw data flows to test, say, in fact, you guys are doing evaluations of routers right now. So you end up needing to generate, I mean, that's even harder, right? You want to generate enough flow to actually even test the router. We did it with SSL. How many SSL handshakes per second can you terminate on this kind of device or that kind of software? So then, of course, build chain environments are sort of, they're almost for development, but it turns out that the people that call us to task are the QA folks. Because when we build a set of software artifacts to deploy onto systems, we need to be able to, you know, do that so that when we have a bug or a defect that's identified, that we can force it back to the appropriate build and then plan impact analysis, what kind of releases to fix it. And something that happens often in a corporate environment, somebody will come to me and say, I want you to build that just like you built it last November. November 4th, as a matter of fact. But I just want you to put this one change in. You know, because hey, you know, we got a customer that doesn't want to upgrade anything else, and they want a minimal change solution for just that piece of stuff you built last November. So that's kind of tricky to do. Because on my workstation, I'm like, last November, what? It's months past that, right? So same thing with release packaging, that for any given artifact that's discovered in the field or in the lab, that you have a very tight relationship back to the source code and the tool sets, the tool chains that we use to build it. So now cloud is also sort of that, but almost after all the versions or releases are done, then you begin to assemble them into virtual machines. So now the level of granularity is a whole machine. It's the whole operating system, storage, everything that I need to run that. So now you get to the notion of, let's be able to define a machine type as a virtual machine, but you know, in one lab I'm running it in VMware, another place in the lab I might be using Zen virtualization or KVM virtualization. So how do I even have then these notions of virtual machines that are sort of understood as whole pieces? So that you can say, well, I need 2 LDAP servers load balanced, I need a database server, and I need 3 application servers. You know, it'd be nice to be able to choose it at that level of abstraction. InfoSec guys, yeah, this sentence is how do you, in these places where you're running with these kinds of, say, even in a managed hosting kind of world, you have clients with very strong or rigorous security concerns. How do you prove that we haven't done something that would decrease their information security in a virtual machine environment? So we're back to software assets. especially when, in fact, you look at it with the Amazon cloud offerings. You know, hey, you can now do your, what's the vector computing you can do with those video cards? You know, and you might want one of those, you know, and at whatever version, or you want a Hadoop cluster. So I need a name node, I need other networking nodes, etc. So you end up building these constellations of components or systems to address larger tasks. In our transcoding work, we would like to spin up sets of transcoders. This is coming in off PAL or MTSC or whatever, and I need to transcode it to iDevices. I got Windows Media I got to hit, and Flash Media Server. You know, so, and there's an event that's, it's a periodic event, so you spin up these transcoders so that you can do the transcoding task in a relevant amount of time. But you don't want to keep them around. After you've done the transcoding task, you want to, you know, just let them quiesce, right? You don't need to have that running if you're not running transcoding. Now, then you get into monitoring systems, and we're really big into monitoring. In fact, Chris is even bigger into it than the application guys are. Because you end up having to watch the impact of this, and I guess people call it fungible capacity. You all heard that term? So fungible capacity is kind of capacity that's like an accordion, which you can grow and shrink as demand requires. Well, with this fungible capacity, it makes it even harder to do the resource plan. You know, and in fact, you don't want something to grow to where it starves out other processes. And oddly enough, it's a little bit of animal because sometimes we get busted for slowing the system down. We put in this really neat feature, V9, you know, it's great. Oh, too bad we didn't take enough time with our algorithm. And maybe the computational complexity, we used a data structure or a search algorithm or something that was not fitting, and it slows down. And Hannah complains. What did you guys do to this? It's a lot slower than it was last time. Or we might even make technology selection changes to get speed ups. You run on older equipment. You run on older operating systems, older copies of, say, a JVM. If you can migrate that forward into a more recent kernel on current, you know, multi-core hardware, Java 1.6 or whatever, you can actually get tremendous speed-ups. And the way we get credit for doing those things is referring to the output of the monitoring systems. In fact, if I turn on the VPN, if y'all are interested, I can show you even a graphic visualization of some of the monitoring systems that we had built around the DNS component so that we could get a better understanding of the performance of our outputs and implementations. So, and then route optimization, this gets to an area that gets closer and closer to sort of the, I think the hard research that was done in the past, and I think that we can continue to pursue. This is where I'm more interested in the real innovation. I'm not sure, as a software engineer, we can write programs that will fix collocation or fix the managed hosting. Although we can address those issues, that's not the real sweet spot of where we can provide innovations at Internap. So the first one is sort of where I get to on the notion of studying the internet itself. When we talk to a router that's a border router, and we get the net hops associated with all these prefixes, we pull that together from our multiple network service providers that give access points, and then you build a network topology, and then you begin to probe that network topology, you get a sift through net flow and S-flow records to understand that system under measure. This is where the KDO work really has been long, and that we would like to, I think we can do some work that, of course, we compute on it right now for IPv4, and we're building the different parts that we need. But in this area, for example, getting the AS pass for IP version 6 prefixes and how I choose what addresses I will probe out of those prefixes. Because in order to probe a network, you need to actually have a host that you're going to. In IPv4, that's fairly easy to guess. Almost, you know, it's almost trivial. You know, but when you have an IPv6 address, the likelihood that you're going to pick an IP address to probe and actually hit one is the probability is much smaller. And in fact, this is the area where I think that the Planet Lab kind of work might be interesting, because I'm not sure I've seen a lot of people do global, worldwide measurement of IPv6 of the sorts that are interesting when you're trying to build or implement a routing algorithm that provides some optimization. And we use the word topology here, but it's almost topography as well. Because in my GeoDNS portion, I have very low-grade information or geolocation information for IPv6 addresses. So for IPv4 addresses, that's fairly well known. I have very large databases that do geolocation nicely. And I have fairly good ways to address when we identify deficiencies there and work to correct them. For IPv6, right now, like MaxMind, it only has country-level geolocation. That does me almost no good, right, in the U.S. Oh, I know you're in the U.S. Where am I going to send you? You know, flip a coin? Maybe I'll change, throw out geographic proximity altogether. Is there some other way I can choose to pin you to a content edge rather than geographic? But yeah, so right now my IPv6 geolocation database is very cool. Data extraction, this is a whole other area, and actually for folks that are interested in data mining or even adaptive systems, it turns out that this may in fact be the most interesting portion of work, because we have a tremendous amount of hosts, routers, switches. We have a tremendous amount of information we can get from these devices, and when we pull it together at various places. Maybe it's right way out there at the access point. Maybe it's further in. Maybe we've aggregated it all the way up to be a global set of numbers. But the tricky part is that we're doing this log mining for multiple reasons. If I only had one reason I was looking at the logs, it might be a lot easier, right? Then I could maybe have a fairly straightforward way of handling it. But when I'm trying to do my resource allocation, or where do I put a new POP, let's say that I'm seeing a lot of traffic out of Brazil, right? Do I put a POP in Brazil, or do I accelerate the transmission from the edges of the POPs we already have that are closest to it? Do I, now of course usage for billing is probably, I don't think we have a representative from the finance group, but they would say this is the most important. Because we bill on a 95p or whatever, you know, and how did you calculate that really? And how do you prove that what we billed for was what someone used? And then of course the nightmare case is when you actually have the problem diagnosis or root cause analysis. Something went bad, something has failed, and so then we want to discover very quickly where that is so that we can mitigate it. So that's on in general, the route optimization pieces, and then this really gets to when we talk about what kind of new research can we do in terms of even protocol or algorithm development. An example right now is for a BGP monitoring protocol, it looks like it architecturally that's the most appropriate way for me to receive the routing topologies from these routers. Unfortunately, only one company router supports it. Well, we're not surprised because it's still a IETF draft, right? In fact, it's a draft 5 at this point, you know. But so in that sense, you know, we think it's correct architecturally. So we might say implement that as a nice component boundary or an interface layer. But there's no implementation. So this is a protocol that we're interested in that's being adopted, or we're going to be one of the early adopters for. And that's just for a particular need in terms of being able to construct these routing topologies and in a happier fashion than say an SNMP polling of certain voids in the router codes, etc. So now live streaming in HTML5, I'm not sure people have really thought about how do you get the content from a publishing or an ingest point out to an edge so that you satisfy your viewer community, and that as more viewers come online, that you might even do, what was that, spanning tree, right? We use spanning tree in a lot of different places, and what was it, 10 and 10.2 or some multicast problems, you know, that were trying to address that. But when you go into the world of HTML5, there may in fact be a new way to do this that maybe minimizes transit cost, minimizes latency, maximizes some other factors. Now, CM had put in this software-defined network research. So you guys may be able to help me with what this actually is. I believe it's a class of applications that, in a more interesting fashion, get information, and I can't help but think of the control. That's usually where I live, in the control planes. But there is the data plane, and you probably know more in terms of the router technologies, how this actually works. But it's an open standard, I believe, are being adopted, say OpenFlow, for where you can build, say, software routers. And certainly once you go into the land of cloud, you know, you might have 3, 4, 5 racks of machines that are all running virtual machines, and you have virtual networks and virtual subnets, etc. So the idea of actually writing software that helps applications in the cloud find and talk to other applications in the cloud will become even more interesting. And so even though, like I said, we use software-based routers like the Quagga. In the Linux world, it's Zebra and Quagga and those sorts of things. There becomes even more reason to do that, to build routers or virtual routers that address issues that arise in the cloud computing space. And of course, I think that they're, given how much we use sort of software-based routing techniques as well, that in the pure networking technology space, they're also applicable. Of course, sometimes we just want to do it in silicon. So, like, you know, just for fun, in terms of that, like the CDN, my CDN pops that are fairly large, we have 40 gigabit uplinks through Miro. You know, our medium ones are 20 gigabit. You know, so that's sort of a crazy kind of transfer rate that we want to achieve. So that gives you an idea of the scale, even if you're going to do some packet sniffing. I don't know if you guys have ever tried to packet sniff at even 10 gigabits per second. It's kind of tricky. So there's certain kinds of things that at these massive scales that the way we used to do it on a 10 megabit per second interface card no longer works. You know, so it's sort of it would be interesting to look at the problem space and think sort of deeply about it and invent new ways to do things that were perhaps done previously. Do y'all want to go back, visit the slides with discussion, or how do y'all want to?
I was curious to know what a few things about the cloud service that you have.
Right.
So one thing is, what is the mechanism for communication between these virtual machines that you have? Is it TCP based, like MPI, or is it things go to the storage system and then users need that thing to pick up the file system?
Yeah, because now, interestingly enough, the cloud storage piece actually defines something called Swift. And so they invented this way of interacting with the storage. And it's done as a REST interface, interestingly enough. So when you talk directly to the cloud storage portion, it's over TCP. Now, a lot of the monitoring interfaces that we have, in fact, we've got an event bus. We're trying to figure out whether it's still a good idea, but several years later. But it uses UDP. That in order to achieve really high rates, sometimes you don't want to wait for a lot of handshaking and stuff. So a lot of the monitoring pieces, of course, if we're sampling anyway, maybe dropping some packets on the floor is not so traumatic. And like I said, there are a variety of layers built on top of either TCP or UDP. Like our event bus, we defined our own sort of protocol on top of UDP that is used for this fast transmittal of messages that fit within a single packet. Now that's a problem sometimes, because sometimes you want to say something more than will fit in a single packet. So yeah, we end up using, what was it? IMPI or IPMI? IPMI, that's what Terzo was just working on his piece for that. I mean, almost, when you get into this realm, there's more RFCs than you can shake your mouse at. And so it really turns out that just in Miro alone, the list of RFCs that you have to be compliant with is kind of huge. So in the various different parts, there end up being different protocols at play.
Yeah, actually, we can also introduce our department information. So actually, many areas match our research areas very well. Right? So for example, in our department, 5 young faculty members are working in the area of networking, including security, sniffing, and routing is a strong point in our department. Actually, almost all the young faculty is working. Dr. Rahim Beya is working routing, of course, wider networks, also wireless network, and also security. Right? My area is right now just starting to working on the cloud computing. Right? And we established a new journal, cloud computing journal, the first one and the only one in the whole world. Right? I'm the editor-chief of the journal. And our work is basically very much yours also. Data storage, how to replicate some nodes so that high availability, high reliability. Now, if you replicate too much, overhead is too much because you have to copy so much traffic. If you replicate so little, then the performance is still low because it's remote, right? So you have to balance how many locations, when to do the copy. So this is a research area, and we're also doing fault tolerance, right? And many students are working in the area of performance measurement and modeling and analysis and routing algorithm. Dr. Rahim, maybe you can introduce a little bit about the research and.
Sure. Yeah. So you can hear me from back here, right? Yeah. I usually talk pretty loud. So I work in a couple of areas. Security is a general area. So I do work in sensor networks, I do work in covert communications, intrusion detection, somewhat at high speeds. I don't know if you've heard of LANCO, but my advisor, John Copeland at Georgia Tech, and then at Stealth Watch. So we've done work with intrusion detection at various speeds. I think one of my PhD students, Marco, will be working with you guys. So he's doing work in sensor security right now. Also, in general, like performance, improving the performance of various protocols, so wireless networks, wired networks, sort of all the entire gamut. We do a lot of work in many different areas, and I think there's certainly some overlap with what you guys are doing, so I'll try to stick around and introduce myself and talk personally.
So, any question, students feel free to ask. Right? I hope in the future not only internship, eventually our PhD students can play a major role. The graduate get a job, play a major role in research, in improve your products. Right? So any questions so far? Stephanie, you're a PhD student, right? Are you working?
Turn the light on.
I'm working more on visualization and
Visualization. Now, another potential area we can work,
I
right?
was just going to also mention about the mapping, the Georgia State map.
Oh, map project. Yeah.
Map project, which allows incorporating geolocation along with other data.
That's right. Right now we are doing a mapping project. Basically, GSU, all the buildings, all the facilities are going to have a sensor network. So put the information. So the whole map is not physical map, just intelligent map about all building. Even in the future, maybe table side, maybe it is so. So this is a mapping project, and we are doing work with IBM, and they just give us a talk. Basically, we try to combine their research with our research in the field. Their mapping is about it's called Splash, right? That project Splash, so basically intelligent world about everything. So this is very similar to we are going to use visualization and use sensor networks, right? And this is an area we are working.
And that's a place where IPv6 plays very nicely.
That's right.
Because
Yeah,
you want addresses for all these places. Right?
How to find the physical location. Now, another area we can work on is, for example, data mining. How to mine your log file so that we can provide meaningful information to you, right? Like billing, like you said, billing, and there's a bottleneck. All these are important, so we can also work on it. These are students working in AI, machine learning domain. However, they can apply their knowledge into network because log file is data, right? So as long as they understand the basic idea of networking, they can still work. So maybe some students working in this area also can apply for this kind of internship. Right? Students, any questions? Feel free to ask.
Yeah. Are you looking mostly for graduate students or also undergrad students for this positions?
So you can also, actually, undergraduate students, for them, it's easier to hire. Graduate students, we have to get a permission for internship permission, right? International students, right? Undergraduate, you can hire part-time and you're working as a study. Is that true?
Yeah.
The same thing.
So just while we are thinking about our discussion, hit that light for just 1 second. This is kind of a fun. This was something that we did for understanding where our hits were, and really this shows us the difference. In fact, this is the next one might sort of show you the difference between BGP hop count locality versus geographic locality based on IP to lat long lookups. So, for example, we have an internet server here in ACS, American Cancer Society, and we only saw 1,500 roughly recursive resolver addresses in the last minute. And so our notion of a terzo measure was that this is the proportion of IP addresses that are geographically closer to this location than any other location. So it turns out, if I'm probably going to pronounce it wrong, but it's a Voronoi diagram. Yeah, so the tessellations and that diagram, actually, this is the degree to which the geolocated addresses fell within the appropriate hole or whatever, right? And so it's kind of interesting as you flip over and you look at, say, the edges. Now this was HTTP edges. Of course this is something that we really built for understanding our resource allocation, for example, and how well we were doing pinning. So these are actually HTTP hits. Of course, now those 1,500 recursive resolvers might translate roughly into the actual end users 34,000 or almost 35,000 edge hits at ACS. So it's sort of interesting just for fun, and we can look, say, go back to the top. So compare that to, say, Chicago. Turns out that also if you're interested in DNS, you might know you can have a primary, secondary, and tertiary DNS server. So we have, originally we had done our allocation of which of those anycast addresses a particular host announced was based on continent. And then through analysis of actually the hits and the latency, we realized that was a mistake. So then we really want to offer a primary and a secondary in every continent, if not a tertiary in every continent. So, for example, another LAX has a lighter amount of traffic, oddly enough. Here's New York. But then you go over to Europe, you might look at, say, the anycast traffic that shows up in London or I think I've got one in Frankfurt. Now it's kind of interesting. So, in terms of a statistical analysis, you've got this large amount of addresses. So I'm getting this geolocation information as a result of pawing through the DNS logs themselves, doing geolocations of these IP addresses that I see in my logs, and then I'd like to correlate that to this view, because this is the results of me having done a geolocation. So let's go, say, Chicago or Dallas. So Dallas is actually a trouble spot I've got. In fact, my terzo measure is nice. If you look at that graph, you're like, oh, that seems a little spread. And sure enough, we have an extremely low terzo measure. So even the definition of a measure that have a single scalar that you could graph or look at, and it be representative of the goodness of whatever that is that's under monitoring or observation. You know, you end up seeing something really funny. One of the fun things to look at is like Boston. Turns out that because Boston is the furthest east U.S. continent pop that we have, all of our customers that did not sign up for EU coverage from a sand pop location has to get their content resolved from Boston. So of course now it might be interesting, our sales guys, we don't have one of those representatives here, but might be really interested in what customers' content are those visits from, or those views from. Because they should send a sales guy over there and say, you know, hey, you need to pay for this EU because you've got a high. But yeah, so then we have you know, even Asia Pacific, you know, like Tokyo or Hong Kong. We end up, now we don't have any pops in India or the Middle East or Africa. So one of those kinds of resource allocation questions being, what is the viability of pop there? You know, so here, for example, in Hong Kong, you see a lot of traffic in India as an example. So one other thing that we do sometimes is we have geographic restrictions that you can place on what pop will serve what geographic region. And so fairly recently, we allowed Toronto to serve Europe, and it turns out that, interestingly enough, these guys are the closest geographic region to Toronto, which is sort of interesting because that shows the poorness of my visualization here, right? I've got it flattened out, and it really seems quite surprising that all this stuff that's seemingly east of Boston is actually closer to Toronto.
We are talking mainland China. Mainland.
Yeah, no, not yet, I don't believe.
Only Hong Kong.
Only Hong Kong thus far. So, I mean, that's a good example of, and it's almost on but, yeah, so that ends up being a place that if you were going there, you would almost have to do IP version 6. You know, that's a consideration. They have so many folks with computers and addresses there that they're almost entirely out. But sort of interesting because looking at this is like one of this flat visualization. Another kind of visualization is actually one of my favorite charts. See if I can get it to zoom in. Yeah, this ends up being an interesting visualization of the topology of IPv4 internet and IPv6. And if I can pull up the PDF, it's well worth looking at these guys. If I can pull up the PDF, it would be more interesting. It actually shows how they have mapped. Of course, it's the surface of a sphere, and then there's a transformation such that every point on the surface of the sphere is mapped to some point on the circumference of a circle. Then further, if you're viewing the topology of the internet of ASs as a graph, we have a well-defined notion of in degree and out degree at any given node. So the higher the in degree and out degree is, the closer to the center of the circle you move. So you essentially have, this is a projection of a fairly abstract space, topological space, onto a fairly simple diagram. And of course, it also shows you visually, you see almost immediately, well, the uptake in IPv6 hadn't been that huge yet. Okay, so there's a lot of room to grow as these folks move over into IPv6. But to me, that's a fairly interesting graph. Now, what I'd really like is instead of my silly graph where I've unrolled the surface of the globe as some flat space, what if my visualization were shown to me this way? Does that give me better information about what it is I'm looking at? Okay, and like I said, we copied up the visualization I showed you a minute ago. It's kind of fun because we're actually sniffing on the internet interface. We're doing a shallow parse on the packet to pull out the information, doing the geolocation on a POP local machine. So they multicast that monitoring information. We're speaking of protocols. We multicast that information to a local collector. Oddly enough, it's called CIS. CIS1. And that actually does the geolocation work and the transformation into a two-dimensional image, and actually drops out a PNG file, and it actually drops out a JSON file, formatted file of the information.
I have a question. Bring up that mapping project, because there's a set of surveillance cameras around campus that
Right.
are monitored by police, but this mapping project wants to use the video feed from there to integrate it into this project using the geolocation. But anyway, they're kind of at a point that there's security issues and communication issues. So is that like an infrastructure as a service example that you're talking about?
Yeah, in fact, you've got, and once you start to think about the infrastructure comes in a lot of flavors. You know, so some of it is the devices, which in my ex-Windows world, you know, that's sort of that device is a server, that video camera is a server, that feed to get from that video device to a host. That's a service, right? That's a piece of infrastructure. You know, now I'm less concerned about it now than I used to. I used to work for LexisNexis or ChoicePoint. So there was a whole lot of questions about privacy of information there, where to anonymize certain amounts of information, say to use for statistical basis or something, you know, so there ends up being a certain amount of things that you would need to do, you know, to respect people's privacy. I mean, I don't think we want to live in the panopticon, right? I mean, that ends up being one of those things where we really need to, you know, be careful about sort of the impacts of the use of our technologies.
And also I want to say something about the potential collaboration. For example, we presented so many possible projects from Internet. And as a researcher, we have to think about their products and the potential say, we propose some new idea. For example, let's say they are analyzing traffic, right? They are doing routing algorithm. Right now, most people use mathematical model or simulation to do prediction. One possible way may be visualize the effect, see what's going on, what's the hottest spot, and so on. So visualization, people can propose the idea, say, hey, I can help in this way, then you can find a job. So maybe they don't have a job, suddenly you propose, maybe it's a job created, right? Do you see my point? Yeah, so I talked to, my meeting with their CEO and the senior vice president, I talked to them a lot, right? And they were, I think, impressed by my talk, right? Yeah, so very impressive. I mean, Georgia State University, we are doing well, we are impressive. Now, potential way, if you just talk to engineers, probably you cannot find a job. If you have some idea, talk to me. I talk to the CEO directly, say, hey, this is a potential project, we can help you, blah, blah, blah. Then they may create a job for you, right? So potentially you can send to me, and this is one way of collaboration also, right? And of course, initially, I hope is what? Potentially find the projects during your study. That's the best way. So not cost them too much money or maybe even no money. Just find the project, right? And then you working on the project. After 2 years, dissertation is done, and this project helps them a lot. Of course, your job is automatic, right? So this is like my idea is like win-win situation, right? As a department chair, what should I do? I hope the department becomes prominent, important computer science department, at least in mathematics, right? Not beating Georgia Tech at compete with them in certain way, right? This is our hope, and we can do it, right? Yes. Together we can do it. Is that true? Yeah. Yes. Now, also I will follow up. You can have many questions you can ask, right? As a follow-up, as appreciation to these 4 visitors, we have a small gift for all of them from IEEE Computer Science.
Because I
Exactly.
drink a lot of coffee.
So we have some low price for the people who are attending.
Low price, also low price.
So in every event we are trying to promote some new technology, and like first event we had some wireless charging and all. So this time we have portable energy storage device. So if your cell phone is out of charge, you can take this in your pocket whenever you want. You can charge your device with this.
The second one is an IEEE limited edition T-shirt. Yeah, we also have some nice gifts for you guys. It's a big giveaway. IEEE.
So this, how many gifts do you have? How many more? Two. Just two. One is here. Okay, so how about this way? Join Stu or Anna, you draw once, you draw one for us. So you draw one. Stu, could you draw one?
The name and here, so.
Oh, you just draw, maybe you draw one here.
Send this to the
Okay. So do you want to announce this? 438483. Anybody here?
483.
438483. Reverse. You got that? No.
I got the 438.
Nobody there. Stu, you have to draw. Maybe somebody.
No palindrome.
438503. Last 3 digits. 503.
503.
503. 00. Okay, good. Congratulations. You want to announce?
Yeah, so
Just one.
I have 438514.
Now, 514. Now, thank you very much, and we still have time. Let's see. spare time, and until 2 o'clock the session will end, right? So question and maybe more questions. Oh, Chris, do you want to speak something? Sure.
First off, I wanted to thank, I'm not sure if I can see any of my co-professors here, especially Dr. Kim. Is he still here? He gave me very hard time.
He's retired, but still want to.
These were the only 2 B's, and all my other grades were there. So I graduated with computer science major from Georgia State in March '98, and I couldn't have been more pleased with the knowledge and foundation it gave me in my computer science endeavors. And one thing I would like to mention is actually today I'm a manager at Internap, and that was the last thing I thought I would be doing in my career in general. I ended up, after graduation, I was a software developer, I was a system administrator, a Unix administrator, I was a security and network administrator, and it just somehow it all converged in QA realm. And to all people who probably are thinking right now, exactly what I was thinking about 5 years ago is all I thought QA was doing is watching the screen and perhaps making sure color turns from green to red and hit the button if it needs. And that's not what quality assurance is about. What my team does is actually write automation code and create and designs and implement test automation framework. In one of the slides that Nick was talking about referred to some of the things we do. So if you, for example, looked at all these DNS and GeoDNS locations, if you at least start thinking about how you test this, how do you prove that it actually conveys correct information, that's just one area. And I will honestly tell you that the project, the QA project to test what he does is still in, in my brainstorming stage. Because if you guys have any good ideas of how to verify that all these GeoDNS red spots are actually in correct locations, we would be more than happy to have you, help us with that. Another example of some challenging projects is how do you simulate everything that takes place on the line network. There are lots of tools that simulate TCP flows, IP flows, or other protocols. How do you collect the statistics of what the average internet traffic looks like? And then once you at least have a close idea, if you do, please let me know because I don't. Then what tools do you develop or find or create to simulate that? So that's another area we are looking at to do. Maybe some other things to get you thinking of quality assurance work is, for example, Nick mentioned the, I remember it was number 2, the workflow, or what was the item on the slide? It talked about the chain. Build chain. So he talked about some aspects of the chain from the developer standpoint. So from QA standpoint, how can you make it so that once the software builds, it automatically tests, it gets tested automatically, results get reported, emailed to the right individuals, and somehow the decision is made whether quantitatively the software quality yields a viable release. This is another framework, or in fact, it's a combination framework, so you may think of it more as a kind of system integration type project to connect software build procedures with software installation procedures with certain tasks that govern which tests get run about which components and what sort of results we care about, who needs to receive this result, and what's the background logic to decide if the quality satisfies a certain level and what that level should be on the first place. So this is some of the challenges TA, and I'd be more than happy, to answer more detailed questions and talk to anyone whenever they need. This is how to test his stuff because he's been bugging me about it, and I just don't have a good answer.
She didn't believe my proof on the whiteboard.
One of the goals of QA is to find bugs, right? So if I run my test and I say, okay, well, everything passed, then I'm probably not forced to run it. The goal is to find some issues in the code. And the more interesting the issues are, right? Because it's very easy to find issues on the surface. How do you find issues with code stability, for example? How do you define the load test on the first place? What should be tested for, and how do we measure it? So this is some of the challenging projects in front of us that will play out.
So do you need a lot of student background in mathematical model besides testing, writing code, or simulation? Like these are practical programming skills, right? Mathematical background, like modern mathematical to shield the performance.
I certainly do. They would still need to write test code.
Oh yeah, eventually.
Just to make sure.
Yeah, that's right. Eventually, yeah. But
Yes,
prediction or killing theory or mathematical modeling is also important, right?
I think we can certainly benefit.
So what simulation, I'm sorry, go ahead, I'm sorry.
Another internship that we posted, I think you posted it here as well, is totally unrelated to the software side. It's more about business units. So we're looking for someone this summer to help work on all statistical modeling of traffic in the network. It's not software, it's statistical.
I think his background is statistics, right? Yeah. He's a master's degree in mathematics.
So what simulation tools, you mentioned simulation, what simulation tools are you all using now?